14. Part A says find the acceleration of the particle at time 3. So you need to tell the person grading it that you know this b of t up here, that phi prime of t, actually we're going to put 3, is equal to a of 3. And then you're going to hit math 8 on your calculator. And instead of t's, use x's, and then plug a 3 in at that last step. And this comes out to be negative 2.118. So you would say the acceleration of the particle is approximately negative 2.118 at t equals 3. So that would be part A. Part B says find the position of the particle at time t equals 3. Well, if you look right here, they're telling us that x of 0 equals negative 5. And they're asking us to find x of 3. So again, this is going to be a fundamental theorem of calculus. So we're going to get the integral from 0 to 3 of the velocity function is going to, I need a dt here, is going to equal x of 3 minus x of 0. So we're going to take our calculator and plug in what the integral of v of t is and get that. You know that this stays x of 3, and then we get minus negative 5, which would be plus 5. Plus 5 over here, and then we're going to subtract 5 from both sides. And when we're done with that, we're going to get x of 3 is going to equal negative 1.760 to 3 places. So it should put at time equals 3. The position is approximately negative 1.760. And that is part B. Part C is you're going to plug both of these into your calculator. And again, you're using this thing. And you're going to plug them both into your calculator. And now the absolute value, I believe, is math, arrow to the right, 1 to number, hit absolute value, number 1. And when you type this in, this first one comes around to 2.844. And then the second one rounds to 3.737. Now you are supposed to tell what these things mean in the problem. So you should say that this thing right here, the integral of vt dt, is the displacement of the particle from t equals 0 to t equals 3.5. And then down here, this part, the absolute value, you should say is, and you should use those integral symbols when you write this, the total distance traveled from t equals 0 to t equals 3.5. And that is the end of part C. Part D says you have a second particle moving along the x-axis and its positions given by this from 0 to 3.5. What time do the two particles moving have the same velocity? So we need the velocity of this object, which you should tell the person grading it that you know this is x prime 2 of t. And then that's going to equal 2t minus 1. Now this is a calculator problem, so you should type this into your calculator, B1 up there, and B2, put that into Y2 on your calculator. And then you want to see where those two things intersect. So when you do that, you're going to calculate the intersection. And when you do that, you're going to get, this would be an x, not really a t. It's going to be at the time 1.571. If you round to 3 places, you can put more in there if you want. And then you would answer the question and say the two particles have the same velocity at t equals 1.571. That would be the end of that whole problem.